Welcome to the next session. Now in this session, we discuss classroom workbook based on the basic concepts of vectors like divergence, curl, directional derivative, angle between vectors, solenoidal vectors, etc. Okay. So let us start the session with classroom workbook. All of you go through classroom workbook. Let us start the session with question number 64. Question number 64. The divergence of the vector field V bar equal to x square I bar plus 2y cube j bar plus z power 4 k bar at the point 1, 2, 3. At the point 1, 2, 3 is blank. It's a numeral question. The divergence of the vector field V bar equal to x square I bar plus 2y cube j bar plus z power k bar at the point 1, 2, 3 is blank. So let us find its divergence. Now the divergence of this vector V bar equal to dou by dou x of I bar component is x square plus dou by dou y of j bar component, this is 2y cube plus dou by dou z of k bar component, this is z power 4 just by definition. Now this is 2x plus this is 6y square plus 4z cube. But we need to find divergence at the point, for example, call it as P. So it is 1, 2, 3. So x value 1, y value 2, z value 3. Substitute these values 2 into 1 plus 6 into 2 square plus 4 into 3 cube. So this is 2 plus 6 fours 24, 27 fours, this is 27 fours. So it is 108. So therefore this is 110 plus 24, this is 134. So the required answer is 134. Note this point. Next we move to question number 65. The divergence of the vector field. The divergence of the vector field V bar equal to minus of x cos xy plus y into I bar plus y cos xy into z bar plus sine of z square plus x square plus y square into k bar is options are given. What is I bar component? Minus of x cos xy plus y. J bar component y cos xy. J bar k bar component sin z square plus x square plus y square. So we need to find the divergence of this vector. Now this is just like previous. So divergence of V bar is dou by dou x of I bar component. This is minus x cos xy minus y plus dou by dou y of y cos xy plus dou by dou z of sine of z square plus x square plus y square. Now when you are differentiating this with respect to x, here we have a dot. So this is a function of x, here it involves x also. So in order to find dou by dou x of this x into minus x into cos xy, apply product rule. So therefore this is minus x into dou by dou x of cos derivative is minus sine. So minus sine xy into xy derivative with respect to xy plus cos xy into dou by dou x of minus x, it is minus 1. Just you assume that this is u, for example, minus x is u and this is v. So apply product rule, dou by dou x of u into v. It is a function of x, even it involved x. So minus x into dou by dou x of this. Derivative of cos x is minus sine x. But here x means xy into dou by dou x of xy is y plus cos xy into dou by dou x of minus x minus 1 plus here also apply product rule. This is u, function of v and even it involves y. So dou by dou y of this. Apply product rule here. So y into dou by dou y of cos y. This is minus sine cos xy into dou by dou y of xy. This is x plus cos xy into dou by dou y of 1. This is 1 plus this is purely a function of x and purely a function of y. Dou by dou z of this gives 0, but this is z. What is derivative of sine z square? Cos z square into z square derivative is 2z. Now let us simplify this. This is xy into sine xy minus cos xy minus xy sine xy plus cos xy plus 2z into cos z square. Now plus xy sin xy minus xy sin xy gets cancelled, minus cos xy plus cos xy get cancelled. So therefore the final result is 2z into cos z square. So this is the divergence of this vector v bar. So the result is 2z cos z square. Just it involved the derivative by using product rule. Here apply product rule. Here apply product rule. Here it is not required. Next, let us move to question number 66. If the vector function f bar equal to ax bar into 3y minus k1z plus ay bar into k2x minus 2z, k2x minus 2z minus az bar into k3y plus z is irrotational, then k1 comma k2 comma k3 are respectively. So in this case we need to find the values of k1, k2, k3 when this vector is an irrotational vector. What do you mean by irrotational vector? A vector whose curl is null vector is called irrotational vector. So when curl is 0, it is called an irrotational vector. So let us find the values of k1, k2, k3 so that this becomes an irrotational vector. Now let us see. Actually this is I bar component. This is I bar, j bar and this is k bar. Now make curl f bar equal to null vector. So therefore this is a del bar cross f bar equal to null vector. Now this is a det of I bar, j bar, k bar. So this is dou by dou x, dou by dou y, dou by dou z. The component of this is 3y minus k1z and this is k2x minus 2z and this is minus k3y minus z. So its value is null vector. Now apply det value. So this implies I bar into det of this block. So dou by dou y of this, dou by dou y of this is minus k3 minus dou by dou z of this minus 2 minus j bar into dou by dou x of this 0 minus dou by dou z of this, so minus k1 plus k bar times dou by dou x of this, you will get k2 minus dou by dou y of this, it is k3. So equal to null vector. Therefore make each component equal to 0. This is minus k3 plus 2 equal to 0. This implies k3 equal to 2. Here k1 equal to 0. Here k2 equal to 3. So what is my k1 value? K1 value is 0. K2 value is 3. K3 value is 2. So the values are like this: 0, 3, 2 respectively. K1 value, K2 value, this is K3 value. Just what we have done is we made curl f bar equal to null vector. You know how to find curl f bar. This is a del bar cross f bar. Apply the det value, make the necessary calculations and make all components equal to 0 so that you will get K1 value 0, K2 value 3 and K3 value 2. Note this point. So here a vector p bar is given by p bar equal to x cube y I bar minus x square y square j bar minus x square yz k bar. So this is my vector. What are my components? X cube y. Second component is minus x square y square. Third component minus x square yz. So options are like this. P bar is solenoidal but not irrotational. Not solenoidal and not irrotational. Solenoidal and irrotational. Not solenoidal and irrotational. That means purely this question involves the evaluation of both divergence and curl. So if divergence is 0, it is called solenoidal. If divergence is non-zero, not solenoidal. If curl is 0, irrotational. Otherwise not irrotational. Okay. So this question purely involves the calculations of both divergence of p bar and curl p bar. So let us evaluate divergence of p bar at first. So divergence of p bar is dou by dou x of x cube y plus dou by dou y of second component, this is minus x square y square plus dou by dou z of minus x square yz. So this is 3x square y minus 2x square y minus x square y. 3x square y minus 2x square y minus x square y, it is 0. So therefore in this case the divergence is 0. Therefore p bar is solenoidal. P bar is solenoidal. Now let us find curl of this vector. Called p bar equal to del bar cross p bar. So therefore this is del bar, this is I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. P bar components are x cube y, next component minus x square y square, next component minus x square yz. So this is I bar into dou by dou y of this, so minus x square z minus dou by dou z of this minus 0 minus j bar into dou by dou x of this minus 2x yz minus of 0 plus k bar into dou by dou x of this minus 2x y square minus dou by dou y of x cube y. This is x cube. So this is not a null vector. This is not a null vector. Just by using component of I bar we can say this is not an irrotational vector. This is not a null expression. So just by finding coefficient of I bar we can easily say that curl p bar is not a null vector. Therefore p bar is not irrotational. Therefore p bar is not an irrotational. So in this case the p bar is solenoidal but p bar is not an irrotational. Note these points. Next we move to question number 68. What it is? The directional derivative of the field u of x comma y comma z equal to x square minus 3yz in the direction of I bar plus j bar minus 2k bar at the point 2 minus 1 4 is. So it's a numeral question. They were asking directional derivative. This is my scalar, this is my vector, call it as a bar, and this is the point, call it as p. So we need to find directional derivative of this scalar in the direction of this vector at this point p. So that is given by this dd. dd means directional derivative equal to, this is del u dot a bar divided by norm a bar at the point p. Here the point is 2 minus 1 4. So let us find del u at first. Del u equal to dou u by dou x I bar plus dou u by dou y z bar plus dou u by dou z k bar. Now what is dou u by dou x? 2x. So this is 2x I bar. Dou u by dou y. minus 3z j bar plus dou u by dou z minus 3y k bar. Now let us replace x, y, z values by these points here itself. So x value is 2. Therefore this is 4i bar. Z value is 4. So this is 12j bar. Y value is minus 1. So this is plus 3k bar. Therefore our required directional derivative is del u dot a bar by norm a bar at the point P. Already the point is replaced. So here del u is 4i bar minus 12j bar plus 3k bar dot product with the vector a bar is I bar plus j bar minus 2k bar divided by its length is 1 square plus 1 square plus minus 2 whole square minus 2 whole square. Therefore this is applied dot product 4 into 1 4 minus 12 into 1 minus 12 3 into minus 2 minus 6 divided by this is root 6. So therefore this is 4 minus 18 divided by root 6. So therefore the required directional derivative dd is minus 14 divided by square root of 16. You simplify this, you get some value. So the answer is minus 14 divided by root 16, root 6. Next question number 69. For the scalar field u equal to x square by 2 plus y square by 3, comma, the magnitude of the gradient at the point 1 comma 3 is, options are given. So we need to find magnitude of its gradient at the point 1 comma 3. Here u is a function in two variables x and y. So its gradient equal to grad u equal to del u. So this is what? Dou u by dou x I bar plus dou u by dou y z bar. I am not taking dou u by dou z because this is purely a function of x and y. What is dou u by dou x? xi bar. Dou u by dou y 2 by 3 into y j bar. Now what is grad u at the point? Grad u at the point 1 comma 3 is replace x by 1. This is I bar. Replace y by 3. This is j bar. So 2z bar. Therefore its magnitude means length. So norm of grad u equal to square root of I bar component is 1, j bar component is 2. So it is square root of 1 square plus 2 square. This is square root of 5. Therefore the magnitude of gradient of this u at this point is square root of 5. Next question. Question number 70. The derivative of f of x comma y at the point 1 comma 2 in the direction of the vector I bar plus j bar is 2 root 2, and in the direction of the vector minus 2z bar is minus 3. Then the derivative of f of x comma y in the direction of minus I bar minus 2z bar is what? This is very interesting question. Here f is a scalar in two variables x and y. Derivative means directional derivative. It is a scalar. Its derivative at this point in this direction is 2 root 2. And the derivative of this in this direction at the same point 1, 2 is minus 3. Then what they are asking is, we need to find the derivative of this f in the direction of this vector at this point. So in the direction of I bar plus j bar, it is 2 root 2. Point is 1, 2. In the direction of minus 2z bar, it is minus 3. And in the direction of I minus I bar minus 2z bar, what it is. So we need to find out this very interesting question. Let us apply directional derivative formula. Suppose assume that this vector is a bar and this vector is b bar and this vector is c bar and this is the point P. So 2 points are given. Point number 1 is this. del f dot a bar by norm a bar at the point P equal to 2 root 2. So let us apply at first. So directional derivative del f dot a bar by norm a bar at the point P is 2 root 2. What is del f? F is not given. So our responsibility is to find dou f by dou x and dou f by dou y. So dou f by dou x I bar plus dou f by dou y is a bar dot product with what is a bar? I bar plus j bar divided by its length is root 2. Square root of 1 square plus 1 square root 2 is equal to 2 root 2. So this implies applied dot product. So you will get 1 by root 2 into dou f by dou x plus dou f by dou y equal to 2 root 2. Therefore, dou f by dou x plus dou f by dou y equal to multiply with root 2, you will get 4. So this we call it as equation 1. Just we have applied directional derivative of f in the direction of vector at this point is 2 root 2. So we got an equation in terms of dou f by dou x and dou f by dou y. It is equation 4. Equation 1. So when you apply in the direction of b bar, I will get one more equation in terms of dou f by dou x and dou f by dou y. So I will get two equations in two unknowns dou f by dou x and dou f by dou y. Solve them, you will get the values of dou f by dou x and dou f by dou y. That gives f. So once you get dou f by dou x and dou f by dou y, you easily get its directional derivative in the direction of this vector. So that is our strategy. Now let us use second strategy. So what is this? Del f dot b bar by norm b bar at the point P equal to this is minus 3. What is the del f? Dou f by dou x I bar plus dou f by dou y z bar dot product B is minus 2z bar divided by what is the length of this? It is 2 only, because square root of minus 2 whole square, yes or no? So square root of 4, it is 2. So therefore this is minus 3. Therefore when you apply this, you will get minus dou f by dou y equal to minus 3. This implies dou f by dou y equal to 3. So when replace dou f by dou y 3, dou f by dou x becomes 1. Therefore dou f by dou x equal to 1. Therefore now let us find del f dot c bar by norm c bar at the point P. So this is del f is dou f by dou x, but dou f by dou x is 1. So I bar dou f by dou y 3. So plus 3z bar dot product c bar is minus I bar minus 2z bar divided by its length is square root of minus 1 whole square plus square root of minus 2 whole square. 1 into minus 1, 3 into minus 2, minus 6 divided by square root of 5. So this is minus 7 by square root of 5. So this is my final directional derivative, minus 7 divided by square root of 5. Note these points. The directional derivative of f equal to 2x square plus 3y square plus z square at the point P213 in the direction of a bar equal to I bar minus 2k bar. So what is my scalar? 2x square plus 3y square plus z square. P is 213, a bar is I bar minus 2k bar. So it's a very straightforward question. Now let us see. At first let us calculate del f. So this is dou f by dou x I bar. So 4x I bar plus dou f by dou y 6y z bar plus dou f by dou z 2z k bar. Now replace these values. So del f equal to x value is 2. So 8 I bar, y is 1. So this is 6j bar plus z is 3. So 6k bar. So the required directional derivative is del f dot a bar by norm a bar. So apply this dot product with this 8 times 1. So this is 8. 6 into, there is no j bar component, multiply with this 6 into minus 2, minus 12 divided by, now let us see what is the length of this. Length of this vector is square root of 1 square plus minus 2 whole square. So this is minus 4 divided by square root of 5. Note these points.